episode of our rooted OSPF campus network with high availability using OSPF. Now, um, as you saw from the previous videos, we've designed our core network, which comprises of, let me zoom out a bit, data center, your main core, collapsed core, and of course your access layer. What you're going to do now is we're going to configure the DR and the BDR, and I'll show you what to do to make sure this becomes a DR and make sure there's a BDR. Check the routing table to see what it shows. Show IPOSPF um, commands to help you identify if the design is the way it should be, and then we can start labeling our layers and putting the interfaces in the right way. I'll show you how to put interfaces by going under the interfaces or um, writing the network commands. So why don't we start with core A? So I'm going to focus in on core A here, and let's open up our terminal here. Okay, let's open it up a bit more. So what I'm going to do first, I'm going to concern myself with FF not here, and then I'm going to concern myself with the loopback interfaces. But before that, why don't you identify which of these interfaces are going to be the backbone interfaces, or going to be part of that area, and then which is going to be in area 1. So why don't you make, let's minimize this a bit more. We're going to make, this is going to be our backbone area, or otherwise called area 0. Our vendors make it area 0 to 0 to 0 to 0 to 0, or they just call it backbone. And we're going to make the data center I like to separate the functions. I can get this up and running. Let's call this area 1. And then the access areas, because it's building 10, I want it to be called, but I'm going to apply this to all the access. So it's going to be area 10. So area 10 over here. Okay. So knowing which interface to put in area 0. Every interface that goes into an area, going into, becomes part of that area. You will see very soon now we have to add interfaces coming down here, going to like some machines here. I'm going to put a switch in here so that represents a work group, and that area will be in area 10. So that interface from here will represent that area 10. The loopback is part of that area 10. This loopbacks is part of area 0. All these links are part of area 0. This zone here is part of area 1. So maybe I should find a way to I'm going to see if there's a way I can sketch this out for you guys to see. And I'm not the best at this because my tool doesn't really work well, but let's see if I can sort of get the picture for you. So let me just launch this tool here, and so I'm going to take my pen here and So I'm gonna try and sketch with my mouse. It's quite difficult, but this bit here, guys, the bits where users will be attached to here. This network here, and that network here, this network here, all these uplinks. Plus the loopback interface here, and the loopback interface there are going to be part of, you got it, area 0. However, this loopback here and anything else will attach into this network here, like that beautiful laptop. Anything else, anything else, anything else are all going to be part of area 10. Now, this network here, anything that will be attached in here, and that could be another server. I can draw my server well. Forgive me, guys, I'm not using the right tools today. I'll go part of area 1. Okay, so that's how it's all going to be. So this plus that loopback is going to be in area 1. These uplinks going into area 0 will become absorbed into area 0. These uplinks going into area 0 are all going to be in area 0, and these guys are going to be in the relevant areas, area 10. Okay, so with that explained, let's go ahead and configure area 0 for a collapsed core blue area. So the tool eventually worked. Okay, so here we go. Core A. What happened? What happened, guys? What happened? I accidentally moved my uh, 5 and 6 here, 9 and 10. Okay. Alright, let's carry on. So core A. OSPF, it's a clever routing protocol. It's link state based. It's not like the distant vector routing protocols available and all those ones. It's a link state. It's all based on links and their states. It's based on gossip, really. It's all about who knows who. OSPF maintains its topology by finding out who knows who, what has changed, and so it's like a neighborhood watch. They keep an eye on what's happening, who's coming in, who's going out, who's gone down, and they all gossip about it. Okay, so over here, see. Let's enable OSPF. These are just keywords, really, but you just type route OSPF, and then the question mark is going to tell you what you can find. It says process ID, so I'm going to use process ID 1. And unlike EIGRP, where the autonomous number must be the same everywhere else, with OSPF, the process ID can be 1 here, it can be 2 somewhere else, it doesn't matter. The only thing that needs to stay relevant is the area. So on HP switches and some routers, you have to type router OSPF enable, but in Cisco it's just router OSPF 1. And one of the ways we can do it is specify the network. So look, why don't I go ahead first and do the loopback. So the loopback is 10.10.10.100, and when I do question mark, welcome mask 0 to 0 to 0 to 0, and the area is area 0. Network again, area 0. Let me type 172.16 dot. We use the 200 network. The 0, and it is a slash 30, but I can't do that there, so it's going to be 0 to 0 to 0 dot 3. Why 3? Because you're going to have to write in 255 everywhere minus your 252, and that gives you 3, which is the 3 here. Okay, alright, so 3 area 0. But you see, nothing would happen if I do show IP OSPF neighbors, for example. Nothing happens. If I do show IP OSPF interfaces, it shows me, if I let's just do interface brief, it shows me that these interfaces loop back 0 on this IP address and mask is part of the OSPF participating interfaces, and so is first not 0 0, but it's waiting. Why? Because nothing else is on the other side. So why don't you, it's waiting on this neighbor to respond. So let's go to the neighbor and get neighbor to respond. So come back in here again, and in fact let's open Glory down as well. So what did you do is have a look here and do show run begin router. So that gives me router OSPF 1. So what I'm going to do is I'm going to do the exact same thing, except that I'm going to change the loopback interface. So conf interface that router OSPF. Like I said, I can change the process ID here if I want to. It just helps for us in networking to make things consistent. So 1 network 10.10.10.99 0 to 0 to 0 to 0 area 0. Network again 172.16.200.0 0 to 0 to 0 dot, you guess right, 3 area 0. Sorry, spaces. Observe your spaces. Okay, and the moment I do that, boom, OSPF adjacencies checked, discovered. It's got a neighbor on 10.10.10.100 who is this guy here, and that is his it's a loopback interface, and it's going to full. Yeah, you see the beauty of it. So when I do show IP OSPF neighbor, tells me that it knows about some neighbors. Let's have a look. Neighbor, this is called B. It says I know about 10.10.10.100. He's my neighbor. Yeah. 172.16.200.1 is a DR, and I am the BDR on 172.16.200.2, which is our desired results. But let's just do show IP OSPF interface. So you know, I am that, and I'm the BDR. Okay, that's what this guy says about himself. Show IP OSPF interface brief. I am this guy, and I am the DR. Right, so we got the result we want. So this guy becomes the boss DR. That guy becomes secondary boss if boss DR goes down. Yeah. So we got that going. Now we need to tell OSPF about all these interfaces, so you should expect some gossip going across here. People call it link state advertisement LSAs. So gonna go back in here, and I'm gonna worry about all the area zeros first, downward towards the axis, and then we do one towards the data center, and then we take it from there. Okay, so here we go. So back on core A, it's very important to identify all the interfaces. So this is what I do normally. I'll say show IP interface brief, and I'll say include all app interfaces. Now every interface that I've turned on, that's it. You see, I just remembered I've not done the F4, so I'll work on that later. It would be a good idea to do that now, actually. So why don't we just do that now? Just sort this out once we're here. Yeah, okay. So conf t interface F4/0 description. Just double check if I've done anything on there. There isn't. So I'm on that interface, so it's description, uplink to oh yes, I worked on that switch but not these. Uplink to data center network, IP address 172.16.100 and AMA.6 255.255.255.252. No shut. Let me see if I can ping from there. Do ping 172.16.100 and that's .5. I should lose and then gain some. Here we go. So okay, so we've done that part. So that's all I need to do, and I'll do the same thing on B. So B, let's see how it looks like over here. Okay. Description. IP address 172.16.100 172.16.100.9. This one can the others. Okay, copy, run, start. Okay, so now we go back in here and let's do what we plan to do. So like I was saying, show IP interface brief, include all the interfaces I've enabled up. So I want interface F4 fast Ethernet 1. I've done this already, but 1 and 4 and loopback to be in area 0. So what I need to do now is another way of, instead of typing network, I can just go another interface. So what I need to do, interface F01, IP OSPF, process ID 1, area 0, exit interface F0, F4. I'm gonna do the same thing. That's easy, that's straightforward. We've already done F0 not, we've already done the loopback. So do a similar thing for our friend on B. That's why it's always good to label it the same. It makes life easier. So I know F0 not, F40, and then F1, F0 1. So show IP interface brief, include F. So these interfaces, we do know that we've already worked on this now anyway, so we can work on the others. And the loopback is already done, so I'm just going to go conf interface F0 1 IP OSPF 1 area 0. So now I want to show IP OSPF interface brief. I want to see all the interfaces participate in OSPF, and I already can see that all these interfaces participate in OSPF. Let's see if we have something that matches that on the A side. They should be identical. So on A, show IP OSPF interface brief, and they're identical. So let's count them. 1, 2, 3, 4. 1, 2, 3, 4. They all resound the same sort of costs and arrangements there. So what are DRCM or BDRs over there? Okay, so we've done OSPF on that level. Let's always save a config, and then we're gonna do our edge, or let's say access to run start. So I'm gonna close these. Now let's go on to this guy. I'm gonna stick in let's take a computer in here. Okay, so I can add more. I can add different ones, and I can actually put VLANs here and still put through different things in here, different subnets. Okay, so we're gonna just do one subnet for now, different network, and we can specify something entirely different, and we want to see that on the network as well. So let's duplicate that. And let's say there's going to be the 172.16 10.0/24 network. So that's this network over here. Okay, we will work on that later. So that's interface F01, F10. Forgive me that. And that's of course the LAN switch there. And I'll put the VLANs on here, and then I can specify different machines on different networks and see how that goes well. If you want to, so we can have different lanes going across different places, but let's just stick to one for now. It's understanding how it's done, and you can break it out anyhow you want. You can use that one switch because it supports the VLANs, or different switches to represent, or you can just pass this through straight, one machine going straight into the interface. But because the router interface, we just want to pass it through a switch, and then we can put many machines in here and see if OSPF can get to them. Okay, so on that switch here, and did I open that switch up? And yes, I did. If I type show IP OSPF interface brief, it should be 0 because there's no OSPF there. Router OSPF 1, and this is, by the way, area 1. Oh no, that was area 10. Yep. So network 172.16.200.8, like we did earlier, 0 to 0 to 0 to 0 to 3 is going to be in area 0. That's this network, yeah. I think is that network over there, and it is. It's 16212 network that is also going to area 0, but not so for the loopback. So when I go down here, and it's area 10 loopback, all zeros. The loopback address is 10.10.10.10. Okay, and then what else? 255. Remember that 172 network? 172, 16, and what are the subnets I chose? Let's check. I've forgotten that, guys. 16.10. 10.0. Area 10. So choose that. Copy, run, start. Show IP OSPF interface. Brief. Area 10 for the loopback. There's nothing turned on for that network here, so you won't see it here. But let's just give this an IP address. So let's start that up. Give it an IP address. And to do that with this, you can just do IP question mark, and you see the format. And this is the format: IP address, subnet, and a gateway. So the IP address we're going to give this guy, a good guy, a good friend of mine. PC2 is going to be IP 172.16.10.2/24. Gateway, we have to specify that. So 172.16.10.254. So what I'll do is I'll save it, and then I'll give that interface 254 F1. So go back on SSA, interface F1/0, description, subnet 172.16.10.0, network. IP address 172.16.10.254, 255.255.255.0, no shot, ping 172.16.10.2. Here we go. So it's able to get to this machine here. So now when I go back here and check my OSPF, what will I see? Show IP OSPF interface brief. And there you go. It knows about this network already because it's live now. Okay. Show run. Begin. Router. Area 10. Okay. Alright, so in the next video we're going to complete the data center and start discovering the entire network from one core router to see if we can see the entire topology, and check the other router to see if it has the exact same database information of where everything is connected to. I hope this video has been good for you. I'd like to thank you for viewing. See you on the next one. Thank you.